All right, let's talk about something we've all run into. Your Java app crashes, throws up a super cryptic error message, and you're left scratching your head. It happens, right? Well, today we're going to change that. We're moving past the basic stuff and diving into advanced Java exception handling to make our code not just work, but be truly bulletproof. And just so you know, this whole explainer is based on some fantastic material from Dr. Sasan Azizian, who really wanted to make these powerful but sometimes confusing concepts totally clear for everyone. So let's jump in and see how we can level up our error handling. I want you to think about your own code for a second. When something goes wrong, are your error messages actually helpful? Do they give you the full picture? If the answer is not really, then you are in exactly the right place. We're about to give your debugging skills a major power up. First up, we're going to put on our architect hats. We're not just going to handle errors, we're going to design them. How? By creating our very own custom exceptions that speak the language of our application. And this is really the core of it. I mean, think about it. If you're building, say, an e-commerce app, a generic ILGRE exception doesn't tell you much. But what about a custom insufficient inventory exception? Now that tells you exactly what happened. You need exceptions that match your specific logic. And here's the beautiful part. Creating one is incredibly simple. It's really just a new class that inherits from Java's main exception class. The real magic is in the name. Just by giving it a specific descriptive name, you're creating a whole new category of error that you can catch and handle with precision. Let's look at a quick example here. We're making a class called myException. See that extends exceptions part? That's what does all the heavy lifting for us. We've also added a simple constructor here that can hold onto an integer, which gives us a way to pass along specific details about the error. So how do we use it? Well, inside this compute method, we have a rule. The input a can't be greater than 10. If it is, we don't just return some vague error. Nope. We throw an instance of our brand new myException, and we package that problematic value right inside it. And this is where it all pays off. In our main method, we can now write a catch block that is listening specifically for myException. This makes our code so much clearer. We're not just catching any old problem. We are specifically handling the one case where our custom business rule was broken. This output shows the flow perfectly. The call with compute 1 works just fine. But compute 20? That triggers our condition, throws our custom exception, and our catch block prints this clean, specific message, caught myException 20. So much more informative, right? And remember, because our custom exception extends the base exception class, we get a whole bunch of useful methods for free. You can get the error message, print the full stack trace, and even find the original cause of an error, which actually is a perfect segue to our next tool. Speaking of finding the original cause, let's switch gears. Architect hat off, detective hat on. Let's talk about chained exceptions. This is all about investigating and finding the real culprit behind an error. You've had this happen. I know you have. One error causes another, which then causes a third. And the final exception you see is just the symptom, not the actual disease. You need a way to dig deeper and find that root cause. That's exactly what chained exceptions are for. They let you wrap one exception inside another, creating a kind of causal chain, a breadcrumb trail that leads you directly from the high-level symptom all the way down to the source of the problem. So Java gives us a few key items for our detective kit. We have special constructors to link a cause right when we create an exception. We've got the initCause method to attach a cause after the fact. And most importantly, we have getCause to start our investigation and follow the clues. Let's see this in action. In our demoproc method, we create a null pointer exception. This is the high-level exception our calling code is going to see. But then we use initCause to attach the real problem, an arithmetic exception, as its cause. We're essentially leaving a clue for our future selves. Now, check out the catch block. We first handle the top-level null pointer exception, business as usual. But then we call e.getCause. This is where we follow the clue we just planted. We unwrap that outer layer to get to the original underlying exception so we can see what really happened. And look at this output. This is a goldmine for debugging. We see the null pointer exception that was caught, but right below it, we see the original cause spelled out clearly. As a developer, this is exactly what you need to solve complex problems fast. Okay, so we've learned to create specific exceptions and to chain them together to find the root cause. Now, let's look at something that's all about writing cleaner, more efficient code. It's time to become the optimizer with the multi-catch feature. Before Java 7, if you wanted to handle a couple of different exceptions in the exact same way, you had to write duplicate catch blocks. It was repetitive and just kind of messy. The after column here shows the modern solution, a single, concise catch block that does the same job. So much better. This is the multi-catch feature. You just list the exception types you want to handle in one catch clause, and you separate them with that single pipe symbol. It is such a simple but powerful way to reduce code duplication and make your exception handling logic way easier to read. In this example, our code tries to divide by 0, which throws an arithmetic exception. Our multi-catch block snags it no problem. But what's really cool is that if the code had instead thrown an array index out of bounds exception, this exact same catch block would have handled that too. One handler, multiple error types. It's just clean. And just like that, we've added 3 really powerful tools to your Java exception handling toolkit. Each one is designed to help you write code that's more robust, more readable, and honestly, way easier to debug. Let's do a quick recap. You can now be the architect, creating those specific errors with custom exceptions. You can be the detective, finding the root cause with chained exceptions. And you can be the optimizer, streamlining your code with multi-catch. With these tools, you can really take your Java exception handling to the next level. And that's a wrap. The real question now is, how are you going to use these tools to make your own code better? Take a look at your current project. Where could you use a custom exception to make an error clearer? Where could a chained exception help you debug faster? The power is officially in your hands. Thanks for watching.